we still see instances, and we will continue to see instances, of attackers trying to make their way into the software supply chain. And they're not necessarily going to go after something like security software right off the bat. They'll go for something that seems like it is completely innocuous, something that most computer systems, or at least a lot of computer systems, tend to rely on. And we saw this happen back in April of this month when we saw the XZUtilities package through the Linux operating system nearly backdoored in real time. And this was a very interesting example to bring up here, because there are some tenets of this that I think we'll see repeated as people are going forward. Now, if you're not certain what the XZUtility is, this is open source compression software that is used by basically every Unix-like system on the planet. So the majority of like Linux computers on the planet, web servers, database servers, things like that, will use this exact kind of software. It is critical, and it's used by multiple other software suites for their just normal operations. It is responsible for maintaining hard drive space, making sure that that software has the other applications it needs when it needs them, decompressing, compressing. I mean, it is a commonly used piece of software, to the point where most people don't actually see the difference between this utility and the operating system of the computer itself. It just kind of seems like it's always there, it always has been there, so it's just part of the native environment. All right, so what ended up happening here? Well, this was an attack that was literally years in the making. This started all the way back in 2021 and didn't actually come to fruition until March of this year. There was a user on GitHub named Jiatan who was trying to become a developer for this product. Because remember, this is an open source software suite. This is something that is publicly maintained by a trusted group of developers, but other people can apply to actually go and work on this software. It wasn't until 2022 that we see the first interactions with this software suite happening. And there was a commit to the repository for this, and then a public campaign, which was basically a social engineering campaign, which was basically slamming the actual moderator and maintainer for this package, and asking for other people to be brought in so that better updates could be made. All of these were what are referred to as sock puppet accounts, meaning none of them were actually real people, but a ton of them showed up all of a sudden and started advocating for this new user to become a maintainer for the package. Flash down to years down the road. Again, March of this year, we finally see a workable proof of concept released into the wild. And this was really sneaky. This wasn't necessarily detectable by most antivirus software suites. It was very hard for people to identify that this backdoor was in the software. So it almost made it into their production version of the utility, which would have then become packaged with basically every version of Linux on the planet for anyone who installed a new version of the operating system. That's frightening. So how did this get discovered? Well, luckily, there was a developer who was working for Microsoft who was doing just a little bit of troubleshooting. And he was looking at some strange errors they were getting with a remote access method called Secure Shell, or SSH. You've probably heard us refer to it before. This is the most, on the planet, this is the most common remote access protocol out there, and so it should be pretty predictable as to how it works. In this case, he noticed that there were some weird errors that were popping up. It was taking a little bit more resources than it should have. It was making the CPU work a little bit harder. And so Andre's friend, the actual researcher, started working backwards with the problem and was able to track this all back to an update that had happened for that compression software, and was able to figure out that now there's something poisonous in here. There's something that should not be here. So he immediately turned around, took that out, and notified the software developers about this. The poison piece of the software was identified. The bad developer was kicked out, and it was just very, very nearly successful. So this was the attacker's plan. This is what they really wanted to do. And again, this was a years-long attack in the making. They wanted to implant that backdoor in the release mode for the software, but not the actual source code, which was a tricky way of making it so it was very, very hard to detect. Then they used that social engineering and pressure campaign to get Linux distributions out there like Ubuntu or Mint or Red Hat or any of the other big ones to actually package this release. Once that's there, they just wait for the releases and distributions to ship out, which is, anyone who's installing a new operating system, which happens thousands of times on a daily basis. And now they have access to potentially all of these systems all at the same time. It was very easy for them to gain access once the code was in place. We've seen some tests of it. And this could have been potentially a much, much bigger supply chain attack than SolarWinds. In fact, some of the news media reporting on this has said this would have dwarfed SolarWinds in both its level of seriousness and the number of computers that it potentially could have impacted. So again, we barely missed that one. But other attackers will be trying to do this. And so from a development standpoint, from a software vetting standpoint, we need to be very, very careful about things, especially when we talk about open source packages in our software.
Even if you're not using Linux yourself, or you're not using a ton of open source products, your vendors are. In fact, we saw with Log4j a couple years ago that many vendors' products that you might not have even thought relied on open source software were relying on these libraries. And it's really a pervasive problem. Thank you so much, everyone. Again, this is Sherry Davidoff, CEO of LMG Security.
And I'm Matt Duran, Director of Training and Research for LMG Security. If you have any questions, please feel free to reach out at any time. We would love to hear from you. You can reach us at info@lmgsecurity.com, find us on LinkedIn, or follow us on Twitter. Thanks again for joining, and we'll see you next time.